All right, so we've all seen the AI revolution just explode, right? It's making everything from our phones to our cars way smarter. But here's the thing. That was just the warm-up act. Today we're going to dive into what's next, a really profound shift that takes AI from just being a pattern spotter to, well, a true partner.
And that really gets to the heart of it. This question is what's driving this whole next wave of innovation. We're talking about a huge leap, moving from an AI that's just really, really good at recognizing stuff to one that actually gets why things happen the way they do. So let's get into it. How do we even get there? Well, the first big step is all about upgrading the AI's brain, so to speak. We're talking about a fundamental shift from an AI that just connects the dots to one that actually understands the lines between those dots. Okay, take a look at this. This comparison is absolutely key. The AI we have today, it's a master of pattern matching, of seeing correlations. It can sift through a million photos and figure out, hey, clouds and rain seem to show up together a lot. But what it doesn't get is that the clouds cause the rain. The next generation of AI, it's all about understanding that cause and effect. And that is a total game changer. So, what's the magic behind this? It's a concept called neurosymbolic AI, and it's basically like giving the AI two different kinds of brains and squishing them together. You've got the neuro part, that's the neural network stuff we're all familiar with, the part that's great at spotting patterns. Then you have the symbolic part, which is more like old-school step-by-step logic. By fusing them, the AI doesn't just give you the answer, it can actually show its work, explaining how it got there. And the payoff for this is, well, it's huge. I mean, think about it. An AI that actually understands why can run simulations of worst-case scenarios to make systems tougher, more fault-tolerant. It can help us invent new things faster because it gets the principles behind the design. It's not just copying what's been done before. And what that all boils down to is creating systems we can truly, actually rely on because they're smart enough to adapt when things get weird.
Okay, so having an AI that can reason is one thing, but that's really only half the battle, right? To really get a handle on our world, an AI needs better senses. So the next big leap we're going to talk about is all about giving it a much more complete, unified view of everything that's going on.
And this is where something called foundation models come into play. Here's a great way to think about it. Imagine an AI trying to understand a story. A typical AI today might just read the text of the book, but a foundation model, it can read the book, watch the movie, and listen to the soundtrack. And then it pulls all of that together into one single deep understanding. It's like one brain with multiple senses. And when we say senses, we're not just talking about text and images. No way. We're talking about an insane variety of inputs. These models can dig into super complex medical data. Think electronic health records or even EEG brain scans. Or, get this, they can listen to the unique vibrations of a machine in a factory to predict when it's about to fail. It's like it can speak all these different data languages and translate them into one coherent picture.
So why does this matter so much? Well, it's the difference between an AI seeing one little piece of the puzzle and an AI that sees the entire finished picture. It's not just looking at isolated data points anymore, it's seeing the whole interconnected system, which is absolutely crucial for understanding what's really going on. Okay, but an AI this powerful, one that can think and sense on this level, that immediately brings up some pretty big questions, right? How do we make sure it's safe, that it's fair, that it's actually working for us? In other words, how do we build an AI we can actually trust? Let's dive right into a really thorny one. Picture this. An AI trained on basically all of human art history creates a breathtaking new painting. So, who owns it? Who gets the copyright? Is it you? The person who typed in the prompt? Is it the company that built the AI? Or, and this is the weird one, is it the AI itself? And this is where our current laws just kind of fall apart. If you look at this, our entire idea of copyright is based on a human author, on originality, on personality. AI throws a giant wrench into all of that. It's pretty clear we're going to need totally new rules to figure out who's responsible and who owns what, when our creative partner is a bunch of code. But, trust isn't just about laws and who owns what. It's also about privacy and security, big time. I mean, if we're going to let these AIs into super sensitive parts of our lives, like our health records or our finances, we have to know for sure that our data is safe. And that means we have to build that trust right into the technology from the ground up. So one of the coolest solutions for this is something called federated learning.
Let me walk you through how it works, because it's pretty clever. Instead of you sending all your private data out to some big central server, the AI model actually comes to your device to learn, so it trains right there on your phone or inside a hospital's secure network. Then, the only thing that gets sent back is an anonymous summary of what it learned. The model updates. Your personal data never leaves. It's brilliant. Everyone's privacy is protected, but the global AI still gets smarter for everybody.
All right, so let's recap. We've got an AI that can reason, that can sense the world in a really holistic way, and that we can start to trust. So, where do we put it to work? The next big frontier is taking this intelligence out of the digital world and letting it loose in our physical world, our actual infrastructure.
Now this is going to take some serious horsepower. We're not talking about your standard chips here. We're talking about next-gen hardware. Things like quantum accelerators, which use the totally wild rules of quantum physics to just turbocharge analysis in fields like cybersecurity. And then there are neuromorphic processors. These are chips that are literally designed to work like a human brain. They're super efficient and allow for real-time decisions right on the device itself, at the edge, without needing to call home to the cloud.
And one of the most powerful ways we'll use this is with something called a digital twin. This is straight out of science fiction, but it's real. Imagine creating a perfect, living, virtual copy of a physical thing, like a jet engine or an entire city's power grid. This twin is constantly fed real-time data from its physical counterpart, creating this perfect mirror world where an AI can run experiments, predict the future, and figure out how to optimize everything, all without any real-world risk. And the real-world impact of this is just massive. With these digital twins, an AI could optimize a whole power grid on the fly. It could help us design transportation networks that can handle anything. It could even tell a factory, hey, that machine over there, it's going to break in 3 days. You should fix it now. It's a total shift from just reacting to problems to proactively and intelligently managing our world.
But look, all this incredible tech, it doesn't just happen in a vacuum, right? For any of this future to become a reality, we have to build the human side of things, the ecosystem to support it all. And this is maybe the most crucial piece of the entire puzzle.
It really comes down to two main pillars. First up, standardization. We need a common set of rules, a universal language to talk about AI quality and safety. Things like standard metrics and documentation, so we can actually measure if an AI is reliable and trustworthy. And the second pillar is people, talent. And I don't just mean we need more programmers. We need a whole new kind of expert. People who are bilingual, who speak both the language of AI and the language of their specific field, whether that's medicine or engineering or law. That's the only way we're going to responsibly connect these powerful algorithms to the real world. So, when you pull all of this together, what's the big takeaway? The crucial point is that we're watching AI grow up. It's moving beyond just being a clever tool that we use, and it's becoming a true partner. A partner that's going to be integral to how we adapt, how we manage our world, and how we innovate. And that leaves us with one last big question to think about. This future, it isn't something that's just going to happen to us. It's something we are actively building right now. So as AI gets woven into the very fabric of our lives, the real question we have to ask ourselves is, are we ready to be the architects? Are we ready to build this thing right? Thanks for joining me.